Sizing submersible pumps is different than that of jet pumps or centrifugal pumps. We will address them one at a time. Submersible pumps can only lose prime if they vortex, suck air from the surface of the water to the intake, or pump the water down to the intake of the pump, causing the pump to lose prime either way. If a submersible pump loses prime, it will run until it is either turned off by a control or destroys itself from heat. Let's discuss how to choose a pump and how they're labeled to help with this chore. The data we need to have is the following. 1. Static level and pumping level of the well at the required flow rate. You need to know how far you'll be lifting water out of the well, tank, or open body of water. This height is based on the distance from the surface of the water to the point of use. In a well, the water level will change as we draw water from the well, so depending on the well's capability to supply water, that change in level can be dramatic. 2. Maximum gallons per minute flow rate needed to meet your needs is dependent on the usage anticipated by the user, which can include fixtures in the house or building, heat pump requirements, and possible irrigation. Irrigation can impose a high demand on one source of water and needs to be considered carefully when being addressed. 3. Total dynamic head required from the pump is the sum of the vertical lift of the water, friction loss, plus pressure to be achieved. This information will be based on the size of the pipe and change in elevation from the surface of the water to the point of use. We then add any fixtures such as water softeners or filters, which can restrict flow. We will be dealing with two different units of measure, feet of head and pressure. If this is an issue, please refer to our video on PSI versus feet of head. To determine the friction loss of your lines, you should refer to friction loss tables for the pipe that you have used. This information is also available via the internet. 4. Well capacity is how fast water flows into the well from the aquifer. A well of 3 gallons per minute capacity can easily be drawn down if we're pumping at a rate of 10 gallons per minute. If you pump at a rate of 3 gallons per minute, you can pump 1,800 gallons in a 10-hour period. In a case such as this, we usually put in a low flow pump and pump into a tank, or if we have a well of adequate depth and static level, the well can act as a reservoir. 5. We need to know what power is available and the distance from the source to the pump. This may seem like an odd thing to consider when sizing a pump. Depending upon whether or not this is a new system or a replacement, it can determine what you can install without having to completely rewire the job site. If you want to upsize your installation, wiring tables for single phase are listed on page 11 of Franklin's AIM manual, which is also available online. As you start to shop around, you will see a pattern in the model numbers of submersible pumps. They usually give materials, type of construction, horsepower, and flow rate. Example, a 5FA05S4 2W230 stands for 5 gallons a minute, half horsepower, stainless steel with a 2-wire 230-volt motor. The fact that the pump is declared to be 5 gallons a minute doesn't mean that it can't pump more or less than that. It is just most efficient at that flow rate. Let's take an example of a pump for a 3-bedroom house with a well that has a flow capacity of 15 gallons per minute. With this information, we usually suggest a 10-gallon-a-minute pump, which will have to produce 10 gallons a minute at pressure from lower than static level. The 15 gallon per minute would have been established from the driller's log if we're installing a new pump and well. For this example, we will say that the house and well are separated by 100 feet and the pump is set at 150 feet with static at 50 feet and a drawdown of 25 feet. With those rough numbers, we will find that we are looking at an estimated 230 feet total dynamic head. This includes several details which need to be considered in sizing. Using the 230 feet of head, we will look at a 10 gallon a minute rated pump, since that is the flow we want and the most efficient design for this application. Looking at the pump curves on a Tri-Seal 10 gallon a minute pump, we can see that a 3/4 horse pump falls short of performing to the level that we want. So we go to the 1-horse model, which will give us a little more performance than what we have specified. Whether we go with a 2-wire motor or 3-wire motor is optional.